Okay, everyone, we're on chapter 13.1, and this technically goes with chapter 12, solutions, but it's in a different chapter, so to keep you guys straight and let you use your book, I just separate them. We're going to talk about colligative properties. This is the change in basically boiling point and freezing point of a solution. So, here we go. Make sure you have your notes and your homework available. The presence of a solute affects the properties of the solvent. So, the one that you're most used to looking at is the freezing point of water. If I add something to a solution of water, I can change the freezing point. Now, this depends on the concentration of the solute, but it doesn't matter what you put in it as long as it makes a solution. The two that we're really going to look at is the fact that the freezing point drops, freezing point depression, and boiling point will go up, boiling point elevation. So here's a better look at this one. Freezing point depression. So the fact that your freezing point goes farther down. Adding a solute causes the freezing point of any solvent to become lower. The amount of the freezing point is lowered is directly related to the amount of solute present. Now this is just like salting the roads in the winter. It's not because the salt melts the ice. It's because the salt makes that freezing point have to be colder than 32 degrees Celsius or 32 degrees Fahrenheit or 0 degrees Celsius. We call this the freezing point depression. It'll look like this. It's the difference in the freezing point of the original solvent, the pure solvent, and the solution of the solvent. I'll explain that better in just a minute. Okay, so the molal freezing point constant, or K sub F, is the freezing point depression of a solvent in a 1 molal solution. So we're going to be looking at molality here. Not molarity, but molality. We did that in last section when we were talking about concentrations. So how much your freezing point is going to change depends on the constant of the solvent and the molality of the solvent. Okay, so here are these constants depending on whatever we're mixing it with. For water, your constant is negative 1.86. If we're looking at acetic acid or vinegar, your constant is negative 3.90. Now this is for freezing points. Look over here at boiling points. Whereas the normal boiling point for water is 100, if we're at 1 molal, the constant would be 0.51. So it's going to change the boiling point there by half. And we'll look at that better in just a minute. So, because you're going to forget all of this stuff, I'm going to point you right here on your green sheet, and these are both of your equations. If you're looking at how much does the boiling point go up, you look to the left. If you look at how much does your freezing point drop, you look to the right. You take that constant, which they'll give you, you plug it in, and you multiply by the molality. Now, look above and find molality. Here it's going to be in orange, okay? That's moles of solute over kilograms of solvent. Moles of solute over kilograms of solvent. Okay, so you might want to write that again in your notes. Molality, or little m, equals moles solute. And that solute is whatever you're mixing into your solvent over kilograms, not a solution, of just solvent, whatever's doing the dissolving. Okay, let's go do some practice problems. Okay, so here's our sample problem. What is the freezing point depression of water in a solution where there's 9 grams of glucose, or simple sugar, and 200 grams of water? So when I mix that sugar, that 9 grams, into 200 grams of water, we're going to drop our freezing point of that water. If I went and put that solution into the freezer, it would have to be lower than 32 degrees Celsius. then, 0 degrees Celsius or 32 degrees Fahrenheit for it to freeze. And then I give you the freezing point constant, okay? So we're going to use the formula that's in your notes, delta T sub freezing, change in temperature, freezing point, and then it's freezing point constant times molality. Now remember, molality has got to be, I'm just going to draw an arrow here, it's got to be moles of solute over kilograms of solution. So we've got to do that first, and then we're just going to plug this freezing point constant in, okay? So you've got grams of glucose, and we've got to change that over to moles of glucose. Grams, and I'm not going to write the whole thing out. 1 mole of glucose, well, you've got C6, so 12 times 6 is roughly 72. H, there's 12 of them. 1 times 12 is roughly 12. O, oxygen, 6 of those. Well, 16 times 6, I believe, is 96. And when you add that up, that should get you close to 180 grams based off my math. I could be wrong. And when I divide there, number of moles should be 0.05 moles. And then I need to put the moles over kilograms. Now notice this is grams. For me to go from grams to kilograms, I'm going to move my decimal 1, 2, 3 places. 3 places, so it's going to be 0.200 kilograms. My molality is 0.25 molal, little m. Okay, I'm going to switch colors here. Sorry, all the dogs walking around in the background. So you're going to take negative 1.86 times 0.25. I'm going to do that down here at the bottom. Times 0.25. Multiply that, and you should get a change. The freezing point's going to go down barely once you do the math. 0.465 degrees Celsius. So basically it'll drop by half a degree. That's not a lot, but it's kind of a big deal when you can add a lot more glucose in and see bigger changes. Make sure you can do this math. Now freezing points will go down, boiling points will go up when you add a solvent. Adding a solute increases the boiling point of the solvent. Now again, it's dependent on concentration, and what we're going to be looking for is the elevation, so the change in the boiling point. Okay, keep that in mind, guys. When I find this is not my new boiling point, this is the change in my original boiling point. Okay, so usually we're talking about water, so the original boiling point here would be 100 degrees Celsius, and if we were talking about freezing, the original freezing point would be 0 degrees Celsius. Okay, so the molal boiling point constant, K sub B, is the boiling point elevation of the solvent if it's 1 molal. Now usually it's more than that, so that's why we have to multiply it by the molality. Okay, so here's our sample problem. The boiling point of an aqueous solution is slightly over 100, so you know that the solvent is water. We need to find the molality. Okay, K sub B for water. So we're going to use this equation up here at the top. So the change in your boiling point, what was the change? If our original boiling point's 100, the change was what? 75 minus 100. Hopefully I don't need to do this problem really, but just to make it clear. My change here, delta T sub B, is 0.75 degrees Celsius. And that's equal to K sub F, or say K sub B, sorry, which is 0.51 degrees Celsius per mole. And we're looking for molal. So I'm going to do a big M there. That's what I'm looking for, okay? You could put an X just the same, okay? Now, to solve for this, what do I have to do? I'm I need to get that by itself, so divide both sides by 0.51. And when I do that, hopefully you'll pause and do some math. When you do that, you should get 1.47 molal is what we're looking for. Okay? Just be able to manipulate the equations that are on your green sheet. Okay? You have homework set 13-1 is your homework. I need you to try all of them. Everybody do all of them. And number 4 is a little difficult, so I might give you some extra credit on number 4. Might be extra credit. You still need to do it because it might not be. Okay? Good luck.